welcome. So the topic we'll be discussing in this lecture is stacks. So you are already aware of stack. We have also discussed stacks in data structures and we have implemented stacks. Okay. So anyway, just we'll have a brief overview of that from the context of computer organization. Okay. But here our stack is the stack is organized little differently. Okay. So this is the stack. So this is the view of the stack. Here you can see the bottom position of the stack. The stack is actually numbered in the reverse way. The bottom position of the stack is it's having the value 10 and the topmost position have the value 0. Okay. Currently the stack is empty. And what is the capacity of the stack? This stack can hold 11 items. This stack can hold 11 items. Okay. And initially what will be the top of the stack? What will I mean what will where will be top will be pointing? Generally we say top point to -1 because in that case we insert from 0, but here we have to insert from 10. So stack should point to where? So we should insert from the location 10. So stack actually should point to 11. Stack should point to 11. Okay, right? And normally for insertion we increment top, but here you should do the reverse way. Before insertion you have to, before pushing you have to decrement the top. Okay, because we want to push from 10th 9th, like that it should go. Okay, fine. So let us see the logic for pushing. So this is the bottom stack. Bottom position is this. Okay, and if already 5 elements are there, then this is the current top of the stack. Okay, that is stack pointer is pointing to the current top of the stack. So we know that the stack is a LIFO data structure, lost in first out. That is the data that entered lost will be the one that will come out first. Okay, right. And how is the logic for push? Let us see. So before pushing, what you should do? So let us say there is a pointer, stack pointer. So initially when the stack is empty, so instead of top we are using SP. SP will be 11. Okay, in this case, because stack is empty. But before pushing, what you have to do? SP equal to SP minus 1. When you do SP is equal to SP minus 1, then stack pointer will become what? 10. So now whatever you push, it will go to the 10th location. Right? Then M of SP is equal to DR. Whatever the data you want to write, that will go into the memory location specified by SP. Memory location specified by SP is 10. So whatever the data you want, that will come here. Okay, fine. So then how we will check whether we have reached the full, whether the stack become full or not? When the stack becomes full, what will happen? If you add one more item, SP will become 9. One more item, SP will become 8. Finally, when the stack becomes full, SP will become 0. So if SP is 0, then full is equal to 1. Then already stack is full. Okay, it means it is not empty. So if SP is 0, then full is 1 and empty is false. So this is the logic for push. Similarly, let us see what's the logic for pop. So when you pop, what will happen? You whatever the element at the top of the current top, return that, and then we have to increment the SP. Okay, because we are coming down means we have to increment. Okay. So DR, data is nothing, data is equal to the memory specified by stack pointer, return that, then increment SP, SP is equal to SP plus 1. Okay, then how will you check whether the stack is, what do you call, empty or not? So if you remove all the elements from the stack, then finally SP will become 11. Okay, if SP reached 11, then it means that the stack is empty. So if SP is equal to 11, then empty is equal to 1, that is stack is empty, and full is equal to 0, that is stack is not full. Okay, so this is how we implement or we understand stack in the context of computer organization. Okay, fine. So so here you can see there is a stack pointer and there is a program counter. Okay, program counter is pointing to some location, stack pointer is pointing to some location, and some registers are pointing to some locations in the stack. Okay, so this is the whole overall logic for push. Before pushing, decrement stack, and then the memory of that stack pointer will hold the data. Before popping, pop directly move the data from the specific memory location to the registers, and then increment SP. Fine, let us stop here. Okay, thank you.